We were talking about version control and distributed version control, and we're going to look at this last part of distributed version control where we have this chain of changes that are built up. It gets a little bit confusing, but let's take a look at some slides that is. All right, we start off and we have nothing in version control, and we start off by somebody checks in 3 files, this file, this file, this file, and they all have little IDs, but don't get all caught up in that. And then this is the commit, this 98CA95 is the commit of these 3 files, and we have 3 files in the repository. Okay, so here we are at snapshot A. This was our submission. We have the 3 files. And the next thing that happens is somebody makes a change. The way you draw this is arrows that kind of extend out to the right. So here is the next person making a change. They've checked in. It could be anything. They could change the files that are there, or maybe they added a new file. We really don't care. But this person does a check-in. Well, now we have a new identifier of our repository at this state, 34AC2. It has this person's new changes that change what it originally had. So you could say we're at snapshot B of the version code of the code. So this is where we were, and this is where we are. And you could just think how this might be useful. So suppose that this person checked something in and it broke the whole project. We could go back and look at the whole set of the files at this point in time and get to things and look at what this person did and kind of fix it. All right, somebody else comes along and they check in something in. Okay, well, this is going to be hanging off of this set of changes, right? Because this is already in the repository, and now this person's checking in. So this changes what was here. And so we keep going to the right, building up change sets, and each change set has an identifier. What I just described was we were making changes one after the other, this change, this change, this change, to the master or the main branch of a version control. So everyone's working off this single branch. It's called the master. If we did one more change, it would be to the right here. And the master is kind of like the head of a linked list. The master is pointing to the latest set of changes. Now on the project that we're working on, we're always going to be working off the master. We're not going to do separate branches, but you should know about this because these separate branches happen all the time when you're working at a company, because you might be working on a set of changes involving multiple people, and you kind of have to check in your progress as you work on this new feature because it might take a month or something. But for our project, we're all going to be working under the main branch of master. But let's talk through a scenario where you do branching. So we had the 3 changes, master is pointing here, but now someone says, well, I'm going to form a separate branch called testing. And so they kind of create another head that's pointing at this point, and they call it testing, and they're going to branch off from this. And then the person that created this testing branch, let's say they check a file in. So it goes to the right off of this, testing was pointing here, but now this builds off of that, and testing is pointing here. Now, if somebody was not working on this testing branch, like say the bulk of your team, they're all working on master. If they were to check a change in, it would go this way off of master. So now we kind of have 2 branching sets of code. So here is kind of just what I said. Somebody made a check-in to master, kind of the norm, and their change goes off of here. If there's another person checked in after this to master, their change would go here, and so they'd be building out the chain this way. But somebody could be checking into testing, and they're kind of building out the chain this way. And keep in mind, each of these boxes represents the entire code base, like all the code is here, right? And maybe they just changed one file, but this is a complete copy of all the code. Now, at some point, you know, that test branch is going to have to fold back in. And I'm going to talk about this again by showing just another example of a branch and folding back in. So we have the master, it points to C2, and here is a branch called whatever, ISS53, represents something. and somebody has checked something into this branch, so it points off of here, the master is still here. Now someone has checked something into the master, so here's C4, and somebody has checked something else into this branch, so here's C5. Now let's say that we want to fold, we want to take the changes that were on this branch here, and we have to fold it back into the master because whatever this little feature was they were doing, they're all good to go, and they want to push it back in. To do it, you kind of have to look at the comment, and there's tools that do this, so it's not like you personally do this. But when you go to merge these two things together, it knows there's this common ancestor C2, and that can help you figure out how you're supposed to merge these things together, because you can see the delta or the difference between here and here and here and here, so you can kind of see what changed, and if they were taking place in files where there were no collisions, where there weren't two things being changed at the same time, you could do the whole thing automatically. If it's automatic, then you're going to get C6. This is the thing that automatically is going to take the changes that were made on this branch and the changes that were made on here, and knowing that you both started here, you'll automatically get this set of code here, and the tool will do that for you. But the problem is, if it can't do it automatically, it's going to pop up a user interface where it says, how do you want me to resolve this change? You changed this and they changed that, and somebody has to win. So pick out what lines of code that you want to have in your final version. That happens all the time. Well, not all the time, but it happens often when you're checking code in and people are working on the same code at the same time. And it can be a little bit tricky to do that merge, because you are looking at a file that was changed by two people in the same place, and software wise you have to figure out really what you want. And after you do that merge, you're going to have to retest it, right? Because if the merge is done automatically by the tool, it doesn't have to be retested because it's clear what's going on. But if you're picking out the changes in this merge situation, it has to be retested because you might have blown it when you manually picked what was merging. That's the conclusion of version control. It can be very, very confusing. And some software engineers make a career actually of managing version control. That's how big a deal it is at a company producing a product. In some companies, they'll actually have multiple versions of the code base for multiple customers, which is a terrible idea, but it happens all the time. So you can just imagine the complexity of managing a software project or product where you have multiple code branches from different customers, but some of the code is the same. It can be quite confusing and elaborate. And that's it for version control.